Okay, a radian is a unit of an angle. Right here we have 1 radian because 1 radian is equal to the same length of the radius. And since this radius is 5 inches, 1 radian is going to be 5 as well.
So for the function y equals 2 secant of 2x minus pi plus 1, the amplitude is 2, the period is pi, the h value is pi over 2, and the k value is positive 1. So our sinusoidal axis is going to be at y equals 1. And graphing 2 periods, we're going to put pi right here and 2 pi right here. And then we're going to put all of the tick marks. So then to graph secant, we need to graph cosine first. And we're going to start at pi over 2, 3 at the maximum. And we're going to come down to the sinusoidal axis and then down to the minimum. And then just keep going up and down. Asymptotes for secant are going to be on the zeros of cosine. And then where the maximum points are, we're going to go up, and where the minimum parts are, we're going to go down.
So we have our tangent graph here. We have y equals negative 2 tangent of pi x minus pi plus 1. Our a is negative 2. Our amplitude is 2. Our b value is pi, so our period is 2. Our h value is positive 1, and our k value is positive 1. So over here we have, since it's cosine, we start at 1, negative 1, and we have all our intervals in between here to 2, so our period is 2, which is right here. So we start at 1, negative 1. We go up right here, or we have our cosine zeros, which are on the sinusoidal axis. And so then we have our tangent zeros, which are also on the sinusoidal axis right here, which are the maximum and minimums. And since it's a negative 2, our tangents are decreasing.
For the function y equals 3 sine 2x minus pi plus 1, the amplitude is 3. Period's pi, the h value is positive pi over 2, and the k value is 1. So the sinusoidal axis is at 1 right here, and we're going to start at pi over 2 comma 1, and go up and then down to 5 pi over 4 negative 2, and then back up and down, and then
So angular velocity is the rate of change of angular position of a rotating body, and the formula for it is omega equals central angle over the time interval. We have a problem that says a propeller turns at a rate of 78 revolutions per minute. What is the propeller's speed in radians per second? So we start off the equation by doing 78 revolutions per minute, and then we multiply it by 1 minute over 60 seconds to change it into seconds. And then we multiply that by 2 pi radians over 1 revolution. And we get 78 times 2 pi over 60, which simplified turns into 2.6 pi radians per second. So now we're going to convert angular velocity into linear speed, and the equation for that is v equals s over t, which is arc length over time interval. And we're going to take 2.6 pi from the previous problem and put it over 1 second, because we're going in seconds, and then times 2.7 meters over 1 radian. So it would now be 22.054 meters per second.